Welcome in, guys, to Rico Coin Report and Konsensus Re in collaboration. This is our third episode of ABCs of Bitcoin and blockchain. Today, I'm excited to bring the letter B to you guys. It's going to have a lot of information. I know I try to pack a lot of information as short amount as possible, but it's going to be a little bit harder considering there's just so much information to fit into this one letter. So I did it twice, and then I put it together, and then I broke it apart, and then I just realized it was just so long that I just had to just kind of wing it and see how we went. I hope you guys are doing good since the last show, and you got to see the letter A, which was quite interesting. We had some really cool, interesting information. If you guys are new, feel free to go over to the excuse me. There we go. Go over to Konsensus Re and go check out what they're doing. They're doing awesome. Nico's doing great. Alexi's got some great information. Raphael, and I do hear Max is also coming out with his own thing. We've been talking about it amongst us in the office, and it's cool because all the projects have everybody's input on them, and it doesn't leave anybody out. So I'm excited. Also, guys, if you haven't gone over to Rico Coin Report, if you're watching from Konsensus, feel free to go check me out. I've got quite a range of different information. I will be reporting a lot of information on the news daily. I do an hourly news check-up, and last night I did one pretty late because I had some technical issues. And also, if you guys want to check out the blog, feel free to go to ricocoinreport.wixsite.com/2018 and go check out the blog. I've got some information on the choices that you make and how these all play a major role in the world. In a sense, you all affect each other and you all affect me, and I want to make you guys realize that the decisions that you make are just as important today as they're going to be tomorrow, and they're going to affect you throughout, and they're going to affect me. So if we can all affect each other positively with good intention, we can get things done quicker. So that being said, guys, let's get right into the show. Again, this is the ABCs of Bitcoin and blockchain, and here we go. From Rico Coin Report, bonjour tout le monde, and hello from Europe, specifically in Paris, but today we're in collaboration with Konsensus Re, and if you guys are checking in from Konsensus, thank you so much. We appreciate it, and for those of you watching from Rico Coin Report, I appreciate that as well, and it's all a big family as well, guys, so no big worries. Feel free to subscribe down below, hit the notification bell, and also feel free to like and comment below if you want to write a little message, as well as share the link so we can get the word out. Alright, guys, today is the ABCs of Bitcoin and blockchain. And today, we're working on a little bit of Blackbird before the show, and it's really hard switching and plucking the right chords at the same time. It's a work in process, guys, but we're not talking about guitars and music today. We are talking about the fundamentals of blockchain and Bitcoin. Okay, so today is a great letter for the blockchain because the letter B, and we're going to be covering, first of all, just what we covered last week in an episode of the letter A, and that was A is for application, A is for anonymous, and A is for Antonopoulos. And if you haven't checked out that show, go check it out. It's super quick and it's quite to the point. This one is going to be a little bit longer. We're going to get right into it, guys. So B is for bear, bulls, blockchain, Buterin, Bitcoin, and the Byzantine generals. Okay, we're going to get into that really quick. So A look at blockchain technology. What is blockchain technology? What exactly are we looking at here? And I'm going to go ahead and get into the second part, and we'll jump back into this part because I wanted to have somebody that we know as Vitalik Buterin in the blockchain space who created the Ethereum network, okay? And if anybody hasn't seen recent, it's gone down in price, sadly, but it'll probably still be used for so many other platforms and so many other reasons. It's a beautiful thing. And I wanted to quote Vitalik Buterin on something he had said at the TechCrunch conference, San Francisco last year. This was on blockchain. Blockchain, an application is an application that is useful for concept or ideas or practices that need shared memory and decentralization. Okay, hence the peer-to-peer transactions, hence the timestamp ledger, and hence the blocks being mined. It's an ongoing world of it's the world of money, really, guys. Blockchain technology can be looked at as the internet of digitally organizing things on a shared memory database. That can be seen anywhere, and you can access the internet or transact or see the updated current blockchain. So this is kind of the breakdown of what blockchain is, in a sense. Is just this public timestamp ledger off of transactions that are transacted peer to peer. Okay, a blockchain creates each block with cryptographic hash, and for each previous block of the previous block's timestamp. Okay, and transaction data generally represented as a Merkle tree root hash. Okay, so it's this long chain of information. Okay, and each time a block is mined, it creates an algorithm or a hash that the previous block will have a stamp from the previous block and the previous block before that, and that'll go into the next block, and that's how everything keeps it on a ledger that's publicly announced to everybody. Okay, and let's go ahead and break down what blockchain is really quickly. So here we have a blockchain, a look at blockchain technology. What is it? And we already talked about what it is, as you guys know. Using this technology, participants can confirm transactions without the need for central certifying authority, meaning decentralization. Potential applications include fund transfers, setting trades, voting, and many other uses. So how it works, if someone requests a transaction, the requested transaction is broadcasted to a peer-to-peer network consisting of computers known as nodes. Okay, now each node is, as if you're running a node, is the application you're running at your house, or where a miner might be using running to mine it as well. So they need to be aware of what's going on as well. Validation. The network of nodes validates a transaction and user status using known algorithms. A verified transaction can involve cryptocurrency, contracts, records, or other information. So it doesn't just have to be cryptocurrency. Okay. Once verified, the transaction is combined with other transactions to create a new block of data for the ledger. Okay. Now, for cryptocurrency, as a medium of exchange created and stored electronically in the blockchain, using encryption techniques to control the creation monetary units and to verify the transfer of funds, Bitcoin is the best known example of this. And we're going to get into that in a second. There is unknowns. So in order to get this, the application to actually work, oh, excuse me. So it talks about it talks about cryptocurrency, and it talks about different applications as well. So you've got the benefits of using blockchain is increased transparency, accurate tracking, permanent ledger, cost reduction. Okay. The unknowns of this blockchain technology are things as how complex this technology can get. Okay. The regulatory implications. Okay, which we're going to talk about at the very end as well. Implementation challenges. What's going to happen when you want to scale or implement this on a mass market or adoption, which is the biggest highlight in a lot of what I'm talking about in my own channel, and competing platforms, so other things that are going to be competing. So there's other potential applications rather than just cryptocurrencies. So the good thing, Oh, okay. So this talks about Bitcoin as well in a second, but I'm not going to talk about that. So blockchain you can use for automotive. Consumers could use the blockchain to manage fractional ownership in automated cars. So if you guys are all owning a car and everybody owns part of it, they can use blockchain for that. There's financial services, as we've seen right now. There's even the idea of voting using blockchain code. Constituents could cast vote Constituents could cast votes via smartphone, tablet, or computer, resulting in immediate verified results. And also, it seems to be is healthcare. There's also some things of if that I've been watching. This was put out by PricewaterhouseCoopers, which is a huge investor in a lot of things. But yeah, this technology can be used for housing. It can be used for buying a car. Any of that information that you need, um, verification and timestamp. Okay, so that's a really quite interesting little map. You can check that out at PricewaterhouseCoopers if you'd like. I have worked with them. They're a massive company. We talked about Buterin, the creator of Ethereum, which is an incredible blockchain code that you can build other platforms on as well. And then now, how blockchain works. It's pretty simple, guys. This is the blockchain network of, for example, Bitcoin. If you want to send money to somebody, um, let's say you are A. Okay, so A wants to send money to B. The transaction is represented online as a block. So you send the money, okay? The block is broadcasted to every party in the network. So all the nodes, like I said, the money moves from A to B. Okay, okay, excuse me. I jumped over there. So back to 4. Those in the network approve the transaction as valid, then the blockchain can be added to the chain, which provides an indelible, transparent record of transactions. Okay, so that is really simplified version. Yeah, so that being said, guys, let's get into the fundamentals of Bitcoin. Now, if you're a maximalist, it's going to be quite interesting because you could just say Bitcoin instead of saying blockchain all the time, because that's kind of what we're really talking about when we're talking about um, the the way it's used in this day and age online. It's blockchain and Bitcoin are essentially Bitcoin is the blockchain, and I talked about this in letter A. So Bitcoin has been called the Internet of Money. It has been called digital gold. It has been called a digital commodity. Let's break down Bitcoin. Bit, a short for binary digital technical meaning. Of information. So it's data. A bit is a bit of it's a digit of data, whether it's a 0 or a 1 or a whole hash of zeros and one. So you've got this information, okay, this bit. All right. Now the stored data executes instructions in other bits to multiple called bytes. So when you have all these bits together, then they can create a byte. Okay, you've got like a megabyte, a terabyte, a gigabyte, that on so far. So now let's talk about coin. Well, coin is money. So you've got data money. So you've got digital money. All right, so that's what Bitcoin is. Now, BTC is a code. Okay, this is the code that is seen everywhere. Not BCH. It's BTC. That's Bitcoin. Okay, that's Bitcoin Core. That means that that's the one that's most internationally adopted. That's not the one that's backed by somebody. It's backed by a project or a group of anonymous people who put this information out. And if you look at the block, the first block, it's called the Genesis block. Okay, now the Genesis block. Sorry guys, I skipped over here. Let's go look at this beautiful thing called Bitcoin for a second. Okay, so this Genesis block has the blueprint, has the information, has the first code in it, okay? And when the first Bitcoin was actually mined was back in 2009, okay? And there's a lot to be said about this because the first 50 Bitcoins were never touched. They were put in a wallet that can't be touched unless Satoshi does something with it. Satoshi Nakamoto, the founder of Bitcoin. If anybody doesn't or does know who he is, that'd be nice for you to share that, but maybe not. Maybe a good idea not to share that. So he's kind of like the Banksy of digital money. Okay, he's the one that set this whole thing in motion, and it's a beautiful thing. If you look inside the block, there's actually a set of information that talks about why this thing was put out in the first place. Okay, it's not because of He wanted anarchy to destroy the world. No, he wanted it to recreate the world. He wanted it to help the world get back on its feet, okay, through the money system, okay? So Satoshi Nakamoto is a legend of all legends, okay? He's the one that set this new sound money in its practice, okay? So let's get into how Bitcoin is. What is Bitcoin? Bitcoin is a currency just like dollars, pounds, yen, euros, but Bitcoin is decentralized, digital money created, held, and spent electronically around the world. How is it backed up? So Bitcoin is similar and different into conventional money, okay? Fiat money is backed up by jurisdiction, okay? It's backed up by people giving it value, okay? The country legally sets it at a price, okay? Through the IMF, the Federal Reserve Bank, and other banks, based off of your debt, how much you owe, that you're worth. That's how much in all this ledger creates the worth of your fiat currency in an economy, okay? And it's a debt-based system, okay? It's governed by central banks, okay? Fiat money takes several days to transfer, and we'll just talk about fiat money really quickly so that we can see the differences. And it costs a lot of money to transfer. You have to pay fees. It's just worthless. And once you've paid that, there is a chargeback if that is possible. So there is a way to get that back, okay? If you really were to press the banks, which good luck with that. Now Bitcoin is different. Bitcoin is backed by consensus of users, by products, by services, in the economy of that is in the cryptocurrency economy, okay? How is it governed? It's governed by mathematics and distributed computing algorithms, rules that have been put there to keep each node from diverting from its track, okay? Which we're going to talk about in a little bit, called the Byzantine generals. How long does it take to transfer? It only takes a few minutes, up to 10 minutes to actually mine a Bitcoin, to mine a coin, okay? That's based off of an equation, an algorithm, okay, that's put into it as well, based off of the Genesis block. So this Genesis block has the blueprint, it has the genetics, it's like the DNA, the RNA, well, the RNA is the one that makes it go do stuff, but it's got its actual genetic code of Bitcoin is in the Genesis block. Okay, there is no chargebacks once a transaction has happened. It says here, imagine a bank account or a credit card. Instead of paying cash, buyers transfer conventional money via to a bank. Bitcoin works the same way. You can buy products on the internet or cash it in other currencies if you wish. What is new is that it cuts out the middleman. So banks and payment companies no longer need to be there. They no longer exist. Okay. So how does this work? Okay. So let's get into the Byzantine generals. Okay. And you know what? Let's jump over here. Let's get into this real quickly. So how Bitcoin transaction works. Bob, an online merchant, decides to begin accepting Bitcoin as payment. Alice, a buyer, has Bitcoin and wants to purchase merchandise from Bob. So, what does she need to do? She needs a wallet, okay? She needs to have an address. So, both Alice and Bob have Bitcoin wallets on their computers. Wallets are files that provide access to multiple Bitcoin addresses. So if you have a wallet, you can recreate a new Bitcoin address, okay, which is recommended for security reasons, and we can get to that when we talk about wallets. An address is a string of letters and numbers such as the code that you see in the following photo. Each address has its own balance of Bitcoins, okay, or Satoshis. This so Bob creates a new Bitcoin address for Alice to send her payments to. So he's got his wallet. He wants some money from her. She's going to send him information. He creates a new wallet. She submits the payment. So submitting the payment, Alice tells her Bitcoin client that she'd like to transfer the purchase amount to Bob's address. Okay, so she takes her private key. Alice wallets hold a private key for each other addresses. The Bitcoin client signs her transaction request with a private key of the address she's transferring Bitcoins from. Now, anyone on the network can now use the public key to verify that the transaction request is actually coming from the legitimate account owner. So with this private key, Bitcoin assigns her a public key, or requests a private key so they can create a public key. Okay. Now, once they have the private key, um, the the address that's being created for the transaction can be verified through the entire system. So it's all verification. This is literally the system in itself. It's all about verification. Okay. Okay. So let's talk about public key cryptography 101. When Bob creates a new address, he's really generating a cryptographic key pair composed of private and a public key. If you sign a message with a private key, you will, which only you know, it can be verified by using the matching public key, which is anyone's key. Bob's new Bitcoin address represents a unique public key, and the corresponding private key is stored in the wallet. So the wallet has a private key. Okay, the public key is used for transactions. The public key allows anyone to verify the message signed with a private key is valid. Okay, okay. So verifying the transaction. Let's say that these guys are miners. Okay, we've got Gary, Garth, and Glenn, the Bitcoin miners. Okay, these three guys are mining. The computers bundle the transaction of the past 10 minutes into a new transaction block. So now this new transaction block is being created within 10 minutes. The miners' computers are set up to calculate cryptographic hash functions. What is that? A cryptographic hashes. So cryptographic hash functions transform a collection of data into an alphanumeric string with a fixed length called a hash value. Even tiny changes in the original data drastically change the resulting hash value, and it's impossible to predict which initial data set will create the specific hash value. So, nonces. To create a different hash value from the same data, Bitcoin uses nonces. A nonce is just a random number that's added to the data prior to the hashing, okay? Changing the nonce results in a different way, in a widely different hash value. Okay, so they have the miners create this hash, okay? Now, a nonce is attached to this hash that the miners created, okay? Now, this nonce creates a specific code, okay? And that specific code has to be verified through the next transaction. It's a verification system, okay? So after the miners create the hash, then the cryptographic hashes are attached. One cryptographic hash has a nonce attached to it, so that way, excuse me, guys, you can. Oh, come on. Let me do a zoom. I can't zoom. Okay, so are you guys understanding what, hopefully you guys can understand what I'm talking about. There we go. Okay, so let's zoom in just a little bit more. Oh, there we go. Okay, so that being said, guys, the miners' computers are set up to calculate cryptographic hash functions, okay? The cryptographic hash functions transform a collection of data into alphanumeric strings, okay? That's collected by the miners, okay? The miners have their own process as well. So, didn't really talk about that, but the miners have their own process of creating the next block, okay? Which is a very difficult system as well, but we're not going to talk about it too much, just in the likes of generosity in this moment. Okay, so once they have that created, then Bitcoin uses nonces, a number that is added to the data prior to hashing. Okay, now in each new hash value contains information about all the previous transactions. So you've got the hash value plus all the previous transactions plus the nonce creates the new hash value. Okay, now what happens to the new hash value? The mining computers calculate new hash values based on a combination of previous hash value, the new transaction block, and a nonce. So they've got to have all three of these things in order to verify. Creating hash is computationally trivial. Is very trivial, guys. But the Bitcoin system requires that the new hash value have a particular form. Specifically, it must start with a certain number of zeros. Okay, so this is also very important. I do believe it's 5 zeros. I'm not pretty sure if it's changed, but so to get these 5 zeros, the miners have no way to predict which nonce will produce this hash. So the value of the required number of leading zeros, to get the value with the required number of leading zeros, to get this code, okay, that it needs to be verified. So they're forced to generate many hashes with different nonces until they happen upon one that works. And that's another multiplication and algorithm equation that has to be checked and rechecked and verified and re-verified. Each block includes a Coinbase. Okay, the Coinbase is the very okay, well, just a second. I'm not going to read about the Coinbase too much, but each block includes a Coinbase transaction that pays out 50 bitcoins to the winning miner. Okay, and then it's halved every 4 years. Okay, so it's going to be halved. It went from 50 and it stayed 50, and then it went down to 25, and so on and so forth, and now it's 12.5, and that'll continue. But a new okay, so the winning miner is Gary. Gary gets 50 Bitcoin, so he's the one that created this new transaction that's been verified. A new address is created in Gary's wallet with a balance of newly mined Bitcoins. So Gary got the win. Everything has been verified. He got his block reward, which we haven't talked about yet, but we're going to get into in a second. And the transaction has been verified. As time goes on, Alice transfers Bob, gets buried beneath the other more recent transactions. For anyone to modify the details, he would have to redo the work that Gary did. Because any changes require completely different winning nonce and then redo the work of all the subsequent miners, such feat is nearly impossible. So they can't change it, okay, once this is already in order. It's being formulated and time-stamped, okay? There's a lot of checks and balances, okay? And the Bitcoin reward is part of the checks and balances to the miner, okay? That's why we have these miners. Okay, so what does that mean? That means if you guys want to send information, you don't need a bank, okay? You just need to make sure that you have a wallet, create a public key from your wallet to send money information to another address, okay? That information is ran through a ton of algorithms. You don't have to do anything, okay? This thing is set up by itself. It's an application on a blockchain technology called Bitcoin that does this for you, okay? It's super smart, okay? It's Byzantine proof. It's Byzantine resilient, problem resilient. Okay, what does that mean? Okay, well, I just told you about before we get into Byzantine. I did tell you guys about. Oops, it's going. There we go. I did say something about the block rewards. So block rewards is why the miners do it, and it has to be verified before they get it. And there's a thing called halving, and halving is in the Genesis block, the equation. So Byzantine generals is how Bitcoin implements verification. Okay, this is going to be a bit complex. Let me just pull up some notes. And about the block order history, guys, really quick before I switch over. Um, okay, so in 2009, there was 0 blocks mined. So the first 50 were mined into a wallet, okay, and then it went on and it wasn't. Oh, excuse me. And so then after that, it was mined as well every 4 years. So it didn't happen until 2012 after 2009, and then it halved again just in 2000 and oh, excuse me, 2009 it was the 50, and then it halved in 2013, and then it rehalved again in 2016, and it'll rehalve again in 2021. Okay, so it's at 12 and a half for the next 4 years. All right, and then in 2021 it goes down to 6.25, and that's what keeps the market sound. It keeps the rate of demand up, and it's just the idea of this whole thing has been placed in the Genesis block. So the block reward is extremely important to the miners and people who are about this market. Okay, so what is the Byzantine generals? Okay, let's get into it now that we can. It's a lot of information, guys. Byzantine generals. It's Bitcoin's fault tolerant system, okay, from problems. It's its verification system, okay. Now, if you were to break it down, there's a picture of a castle with knights around it, okay. Now, if let's say each person is a general, okay, each of these knights is a general, and they want to attack the fort, and the fort it's impossible to attack, I mean, to really take over, unless they all do it all together, or they all come up with a consensus where they all agree that they're going to do it at the same time and combine their forces to finally win capture of the fort, okay? And in this case, it's going to be the block, okay, creation of a block. So that's what the miners are doing, okay? They're literally, the whole system is doing this, okay? It's a verification system. And what it is it's literally having each of the generals, each of the nodes, each of the transactions, a majority at least, are going to be trying to do this the way they're programmed, okay? And the idea of the Byzantine general is the fact that, let's just read it. Okay, in layman's term, it is a way that computer science called consensus with a C does a list of steps and checks in agreeing through equations that the blocks mined and created are in fact okay and sound, okay? So it's not, these aren't, it's an anti-attack system, okay? So first off, Bitcoin looks at each wallet transaction as an enemy until the transaction is broadcasted and a number of results are sent back and with an agreement on the hash or code that comes from the wallet, okay, or the transaction, excuse me. So in other words, if we talked about the nonces, okay? So when a hash is created for the coin, that's the transaction, with a timestamp, the nonce is attached to it, okay? Now, the nonce is only so the only person that knows the nonce is the transaction being put into process, okay? Now, the system needs to do a consensus, so they're all going to be doing equations. And if a majority agrees, the consensus agrees, then the system will place the block in the next chain, meaning that's the next transaction on the public ledger, okay? Now, if there's something wrong with it and it's not, and it's an attack and it's not the correct one and it's trying to force its way through, then the other nodes, the other wallets, the other miners, everybody on the consensus will see this and or will disregard it and not use it. And this is called the Nash equilibrium, okay? It's a gaming term, okay? Meaning if one node or computer finds out the plans of another, it won't change the node's strategy or its strategy to do its job, okay? It will continue on its job to inform the system of the incorrect information and not also switching its strategy to gain anything. Or in other words, one for all and all for one, okay? So if this is wrong, then it's an attack on the system, and it won't clarify, so it will not go through. And this is for those attacks on the miners, the attacks on the consensus, and this is extremely important in how Bitcoin works. Okay, so the Byzantine generals is it's a fault-tolerant system in Bitcoin. Okay, it keeps this problem from happening and from the natural equilibrium to happen. Okay, so if let's say you're playing poker and you knew your friends, if you knew everybody's bets on the table, even though you were not going to change your strategy, you just continue on to your strategy, but everybody gets to know each other's strategy to see who's going to win. That's the Nash equilibrium, okay? The fact that these computers do the same thing. When one gets the hash key, then all the other nodes have to also agree, okay? And if they don't, then that's the Byzantine's general fault problem. Okay, it's fault. Okay, so that way the whole thing won't equivalate. So it's its own security algorithm with a little number that's attached to the hash that only the miners know, the one that mined it, the correct one, and the consensus. All the other ones have to come up with the exact same equation that the nonce gave on top of the hash, okay, with the private key, or the public key, excuse me, and then once the consensus agrees, the verification through the group of all the other nodes, the majority, only then will it be put onto the timestamp and the ledger, and that block will be added into the ledger, okay? So it's pretty complex, but I tried to break it down. Okay, so guys, we're going to finish off with something very simple. We're going to be talking about markets, and Bitcoin is an amazing market. We have the bears and the bulls. Okay, so what does that mean? Okay, what is a bear and what is a bull when you're talking about the Bitcoin market? Well, when you hear somebody saying bearish, bearish is in trading. The two means that you plainly think that the price is going to get worse, that it's going to drop, that there's going to be a sell-off, and you're entering a bearish position, meaning you want to get out as soon as possible, or a short, okay? And you can short this anytime, but that is what literally means to be bearish, to short the stock, to not believe in it, to want to get out, okay? And or to use it to get more, and you can be bearish as well on a market and take, okay? Now, while bullish means you're investing, okay? So bullish means that you're in for the long. That means you're invested for the longer position, that you do believe it's going to go back up, that it is going up, that it's on a positive wave back up, and its value of worth, and its adoption, and its scale, okay? So the scalability. And yeah, so bearish just means that you're not buying, or if you are, it means you're only buying to get more of something else, and you're not interested in the market in the long term, you're in it for the short, whereas the bull means that you're in it for a long position, or a longer position anyways than a you can still be bullish and take a little bit of profit along the way, but most of the time when you're in for bullish, that means you're in for the long, okay? So you're in it to watch the rate, you're waiting for it to go back up, and you're getting it on it now because it's only going to go back up, is how you believe in it. So guys, if this has been a lot of information, I appreciate you checking out all the information on Bitcoin, blockchain, the letter B, and this beautiful technology that's been given to us, okay? And remember, guys, that without your adoption use case ability, this can exist. So it's all about peer-to-peer transaction, okay? If you haven't gone over to Konsensus Re, feel free to subscribe. If you haven't gone to Rico Coin Report, also go check us out as well there. And you can see what we're doing over there. Excuse me, we'll switch it over here. Voila. Konsensus, such a great place to get information, super sound people, and Rico Coin Report. You can find me with interviewing conversations with many of my colleagues, and there'll be a new show coming out soon as well. Merci beaucoup tout le monde. Tout à l'heure. Au revoir. Bonne journée. And don't forget, guys, the ABCs, the fundamental building blocks, it just takes time. You're not going to know it all in one time. So take your time, enjoy yourselves, and until later, au revoir. As well as share the link so we can get